Welcome to this video session. I'm Pierre Le Breton, Technical and Marketing Manager for L'Allemand Animal Nutrition. Glad to open with you this session with maternal microbial imprinting. So as an introduction, we may have some word about what our global swine sector is facing as a context. Our sector everywhere is becoming more competitive. And the first translation is we have an increasing importance of the cost of production. Everything related to the decrease of cost of production is becoming very important. That can come from the cost of the piglet, the health resistance improvement, of course, the control of losses, the improvement of the feed efficiency, and especially today with a high cost of a feed, and at the end, improvement of the milk quality, the carcass yield, everything related to the final product. So in this global context, we are already facing a lot of improvement, and we are organizing a lot of adaptation that create a kind of dynamic situation. In this context, we have 5 main areas in this sector that are changing, that are step by step improving and creating the right, let's say, situation and organization to have the optimal, let's say, condition for the swine and pork production. So we have, of course, on top, the management. People, training of people, knowledge, organization, rationalization and professionalization of the sector. We have this genetic part with a lot of improvement that will also create some change and new needs in adaptation, housing improvement, health improvement, and the last but not the least, the nutritional improvement. And for example, one big change is a change coming from genetic, changing the level of the litter size prolificity that create new situation. And today we can say that almost everywhere, this change is creating a kind of limit that could be expressed in the terms of a piglet quality at birth, that in the same time we are improving the litter size, we are also facing new, let's say, limit coming from the piglet quality at birth. Of course, it can be the weight, but it's most of the time related to vitality at birth, quantity of energetic storage in piglet, and that's our, let's say, topic today, the first contamination of the piglet. And those piglet quality are not something weak. They are very important because at the end, depending on this, let's say, piglet quality, we will influence a lot of final economical parameters. Some of them, of course, the number of sold heads, sold pigs, or tons of carcass. Because we will change immune capacity, we will change the health resilience, animal losses. We can also change the feed efficiency, playing on the speed of growth, of the cost of growth. And again, speaking about the final quality, change the fat deposition, the quantity of adipocyte, and the carcass grade. What does it mean, globally speaking? These piglet qualities around birth or at birth are very important, and they are all coming from the sow. It's an heritage, and they will be able at the end to modify the ability, the capacity of this piglet that will become fatteners and then at the end pork. So when we are speaking about the maternal microbial imprinting, it is classically, we are directly related to this hot topic, piglet qualities. We are speaking about how, from the source gut ecological composition, microbial composition, we are able to play on this one in order to modify, to change the piglet gut ecological composition, microbial composition. So that's exactly the subject. It's a kind of heritage coming from the source treatment that will help to modify, to change the ability of the piglet, speaking about the microbial, the gut microbial composition. So already we can raise some question, how to speak about this, how to characterize it accurately. And then as soon as we are able to characterize it, how to modify it, how to play on some, let's say, criteria in order to be able to optimize this piglet gut microbiota. Some words about the microbial establishment in neonate piglets. At the beginning, the gut is almost sterile. It's nothing inside. The piglet around the farrowing, they will be exposed to a variety of reservoirs. It means the vagina during the farrowing process. It means the skin, the udder. It means the floor, everything related to environment and the biofilm they may face outside. And of course, the south species. All of them will contribute to this colonization of the gut. And it is a very fast phenomenon. We are speaking about 3 hours after the birth, we are already organizing the colonization, and we have already high level of contamination half a day after the birth. And those first colonizer will be able to change the velocity development. They will also create the first immune cell stimulation. That's something very important. They will be in charge. They will be creating the first step for the intestine function development. And in a lot of species, and especially in swine, it is a unique window at the beginning, a wonderful opportunity to change, globally speaking, the ability and the capacity, the health capacity, and of course, future performance of the piglet at the beginning. What is done at the beginning has the highest impact. We will see it together. These topics of microbial imprinting, Lallemand R&D team invests a lot to be able to show what was already known by the field. I remember in farms to see this effect from the source to the piglet. We were able to observe it. Today, we are able to explain it accurately thanks to new scientific tools. And it's really opening a new field for interaction on the piglet efficiency. It means that coming from the treatment, we will concentrate on the gestating sow and lactating sows. We will be able to modify, globally speaking, what will be the gut microbiota, the very first microbiota of our piglet. So in our industry, we are used to speak about source heritage. That's very common when it's come to genetic. So we have genetic shames that will make some selection on some heritable traits. So we have a very nice and accurate definition of the level of heritability of those traits. So here we are not speaking of this kind of heritage. We are more speaking about epigenetic, let's say, impact. We will create conditions on source to provide a specific heritage to piglet. So the knowledge about, let's say, ways to change microbiota, and especially gut microbiota, we know that we have several conditions in our, let's say, modern ways of farming that will interact with this microbiota, that will be able to make some change in the context of this gut microbiota that will lead to change into population. For sows, it's depending on physiological stage, of course, genetic, age, but it's also related, of course, to diet composition. What will be the nutritional intervention? What will be the medication? What will be the physiological stresses? What's happened to the liver? Are we facing constipation? Are we around farrowing? Are we doing the lactation? Are we facing catabolism? So all of those and everything related to environment, heat stress, will create situation where the gut microbiota may change. We may have some variation if we don't protect, if we don't have any specific cares about those population. For suckling piglets, it's same. We have, of course, depending on the age, depending on the size, the age of the animal, depending on the stresses of the animal, temperature, the other access, all the care we will give to the animal, the milk composition, the milk macrobiota. You will see in a couple of slides the huge impact of the milk macrobiota on the piglet. And of course, external contamination, negative biofilm compared to positive biofilm, and the vaginal contamination and the impact of sows feces. After the weaning, same story, exactly the same story. Okay, depending on the age at weaning, depending on the digestive maturity, how we did prepare it, depending on stomach pH, depending, of course, about everything related to nutrition. How long between weaning to the first meal? What is the feed composition? Speaking about nutrient, protein, non-digestible fraction, anti-nutritional factors, contamination, all of those may have an impact on the population. How to describe those populations? So we are not able to speak about these topics of about microbial imprinting, maternal microbial imprinting, without speaking a bit about the method we are using today. And in L'Allemand, it's every day we have some specialists and scientists using many gene expression method. That can be the amplicose-sequencing, that can be the metagenomics, that can be the metatranscriptomics, that can be the proteomics or the metabolomics. All of those are different methods that will express different parts of and different ways to express what are the population inside the sample. Okay, that's different method able to describe microbiome. When we have those information, we may do some interpretation. And in the coming slides, we will use those three main methods, which is the first one, relative abundance, which is one way to describe the proportion of a given species inside a sample. The second one is alpha diversity. It's one way to express for one sample what is the diversity in this microbiota sample. Just one way to express the main difference inside a sample. And the beta diversity, it's a comparison between different microbiota samples and be able to make a comparison. Are they close or are they very different? Okay, so using those three methods, we may have some nice interpretation coming from macrobiota, let's say, sampling. One first example is this one. So it's a global example done on piglet. So in this example, we have been able to separate 24 different bacteria coming from the source. And the color you are able to see on the screen is representing what are the bacteria coming from the milk, depending on the day. What are the bacteria coming from the source feces, in the pink to red color? What are the bacteria coming from the other skin, areolar skin, coming from the other? What are the bacteria coming from the vagina? And what are the bacteria coming from, globally speaking, the environment? And we check, okay, so we have those bacteria coming from the source, and we will check into 4 different sectors of the gastrointestinal tract, so ileum, jejunum, cecum, and colon, day after day, from 0 to 35 days, what is happening, speaking about the relative contribution of the bacteria coming from the source. That's really interesting. And you can see that especially the small intestine, if you look at the ileum and the jejunum, the impact of the milk contamination is something very important. Huge impact on the relative contribution of the milk microbiota from the 0 to the 35. We see that the vagina and the bacteria coming from the vaginal tract are also very important during, let's say, 2 weeks in this ileum, but also the colon. Okay, and if we look at the source feces, we can see that it's becoming very important, something very sensitive from the day between day 1 and day 3. And in those days, especially on the colon and the cecum, we will have a nice relative contribution of the source feces. So here it's a global, let's say, picture already showing that something is happening from the source to the piglet composition. The next trial done by Caroline Achard, coming from L'Allemand, and she did this very nice publication, and it's a nice trial done, of course, on sows, so more than 80 sows. One group receiving the Boulardii, the Levus LSB, normal dose, low dose, 4 weeks prior to farrowing, and then during lactation until the weaning at 21 days, so 4 weeks to the weaning. And another group as a control with no Boulardii. And we check on the piglet with 3 dates of sampling around before farrowing for the sows, the day of farrowing, sampling the day of weaning, sampling 6 days after weaning, and also sampling 20 days after the weaning. So a very long period that has been checked. What are the first information? Here we speak about alpha diversity, showing what are the main microbial changes around farrowing. Here we are speaking about sows. You see that in the control group in gray, if you look before farrowing compared to after farrowing, we have a big classical change, huge change before farrowing, after farrowing in the global alpha diversity of those faeces sample, meaning that the process of farrowing is really creating a huge perturbation in this microbiota composition. Look at the blue one with Boulardii. Okay, we have a small change, globally speaking, but we keep and we are able to really mitigate, that's the right word, really control the impact of farrowing. That means even going through the farrowing, our alpha diversity will be under control. Okay, so it's not the first time, but in this trial, first step was to show that we are able to control, to limit the heterogeneity of this microbiota after the process of farrowing. If we look on the same source, from the same sample, what is the qualitative evolution? Okay, so we spoke about the alpha diversity. Here, we will be able to speak about the relative abundance, another criteria. And we have here, as you can see, three main phylum and very important phylum: Firmicutes, Proteobacteria, Fibrobacteres. And you see, again, very interesting information coming from the trial is that on the control, if you focus on the gray one, the control, we will have a big change in the microbiota. We saw it globally, and here we are able to say that, for example, we have an increase, a quite big increase in the Proteobacteria, okay, coming mostly in this case from Campylobacter genera. This is quite sensitive, okay? This is opportunistic bacteria, and you see around the farrowing, they grew, okay? Big disturbance. And in the same time, we can see that Firmicutes, the first one, Firmicutes, we are facing a big drop. Also something quite negative, because in the same time that we have the improvement of opportunistic Proteobacteria, we have the weak population of Firmicutes, like Ruminococcus, Ruminococcus, that decrease. With Levicel, the story is really different, expressing a very nice control. We have ability, capacity to control the Fibrobacteres and Firmicute phylum. Thanks to the Boulardii, given again 4 weeks prior to farrowing, normal dosage, we are able to control those populations. Those weak populations are protected. And in the same time, we have no expression on the Proteobacteria. Those Proteobacteria will increase a little bit, but they are under control. We are not facing a big improvement in the population. That's a kind of balance thanks to the Boulardii. It was what's happened on the sow. Here it's a link to the maternal microbial imprinting. Okay, we saw that as an example, Fibrobacteres, so bacteria able to process fiber fermentation, so mostly anaerobic, weak, very weak population. If you look inside the piglet coming from control sows, so with no Boulardii, you see that the detection frequency of Fibrobacter are quite low and always below 25%. The same control done on piglets coming from Levicel SB treated sows are more than 50% higher. And for the day 6, it's also more than 60% of compared to control piglet coming from control sows. That's a huge difference. That's really a huge difference, and that's exactly what we are looking for on the piglet's microbial content. Another expression with beta diversity. So just as a, let's say, global information, are we able to make a distinction, to distinguish the global profile of microbiota with or without the Boulardii on the sows? We see on the sows, it's quite clear. The first one, it's a really different type of population. So you see here, we have two main groups very separated. On piglets, 6 days after birth, it's a really different, completely different population. So we can, this graph, I really like this one very much. We can see here that only changing, only playing on the Levicel SB on the sows prior to farrow, we will create a total different population on piglet that the sows receives the Boulardii. So it's really efficient. And if we look after the weaning, so we are speaking about the sow treatment, and 20 days after, and even 5 days post-weaning, we still have a difference in the population. Not that big difference, but we still have a difference expressed in this beta diversity. That's the maternal microbial imprinting. And if we are curious, and in this trial, Caroline Achard has been curious, they check 20 days after the weaning. 20 days after the weaning. That means we did it on piglets 41 days old. And look, this is quite easy to understand. It's very visible data or information on this beta diversity. We have really completely different population of bacteria. That means playing on the sow treatment, using the Levicel SB on the sows, 41 days old piglets are able to show the difference in their gut microbiota profile. So that was trial 1. And of course, coming from a change in this piglet microbial profile, we can expect modification in the performance. And in a second trial, and that we did also with the same shape, treating the sows in gestation, in lactation, and having different, let's say, treatment on piglets, we also have been able to show on the performance of piglet that using Boulardii on sows make a difference, create a difference on the performance of piglet after the weaning. The lucky piglets having sows treated with the Levicel SB express a better average daily gain during the suckling period, but not only during the suckling period, also after the weaning. So we have a kind of a better expression coming from this control of the gut microbiota coming from the maternal microbial imprinting that will be expressed in performance. And in this trial, we show that we achieve the same performance on piglet that has been treated with zinc oxide and antibiotic compared to piglet with no treatment, but coming from sows treated with the Boulardii. That's exactly what we are looking from those maternal microbial imprinting. Okay, so the Boulardii, this specific strain of Boulardii, Levicelles B, is well known for many economical purpose. We use it for boars, for sows, for gills, for piglet, for finisher. And we have a very nice impact and positive impact always. We have a huge capacity to control individual gut microbiota. And what we prove with those publication done on the maternal microbial imprinting, we prove that this modulation in the gut microbiota could be an heritage from the source, and from the source treatment, we are able to modify, to change one key criteria inside the piglet quality. And this first colonization for a lot of species is always the strongest. Of course, the cheapest, because it will create the let's say those first balance equilibrium in this bacterial composition will still. And of course, this is the really first step as a demedication objective. Okay, that first modification of the gut microbiota will be able to be amplified by quick feed strategy and pre-starter strategy. Okay, so in an objective to improve the piglet efficiency at weaning that we are all looking for. So we have what is coming from the sow heritage, Boulardii Levicelles B impact, changing the colostrum impact, changing the glycogen storage, modifying, of course, the vitality at birth, and changing, shaping this gut microbiota, the so-called maternal microbial imprinting. Then when you do this in your strategy, coming from creep feed, what is coming from this suckling period, that also what will happen after the weaning, and especially from your piglet diet, as soon as you have the right population at the beginning, it will be much easier to achieve an optimal answer from your piglet, from a well-prepared piglet. Thanks very much for your attention. Bye-bye.